Hello, Cyberland. So the next thing I'm doing is I'm working on this project with this little XY table, and I need to be able to verify that this side and this side are perpendicular to that, to the spindle. Anyway, my name's Marlon. The channel's Old Fart Hacks, and this is what we're going to be working on is creating a tramming fixture. But we'll get through all that in just a moment. Obviously, I'm at the end of making that, but we'll come back to that. So, onward. So anyway, what we're doing here is doing up the drawing. We do up the outline of the bar, and then we extrude self-same bar, while at the same time copying it over. And then we make up the end piece on one end, the end piece on the other end, do some sketching, put a slot in it so we can clamp, put a little hole right there so that the slot pieces can move, put in the hole for the clamping screw, and then we put in the hole for the indicator. And then the next thing is we make up the little block that goes into this, which we then put a hole in that for the clamp, or for the for the bar that goes into the spindle. We then fill it and split everything apart, bring this down to the surface, bring this up to a common surface, and at that point we export the thing as a file out to the processor for the 3D printer. Isn't this fun? So anyway, this is my new 3D tramming fixture setup. The slide here runs on V-ways, and the bottom of the fixture has the self-same said V-ways. And the only problem I've got is, as I said, I 3D printed this, and it left lips on the sides here, which bind up. So I'm in the process of sanding this down. And then once I get it all sanded down and sliding smooth and installed and make up the necessary hardware to clamp and so on, the dial indicator goes here, a clamp goes across here. This hole is this the threaded side? Yeah, there's internal threads there. We'll see how they work out. Anyway, and then of course there's a stud that goes down through the top and sits on this. So I'm going to get it all done up. I'll bring you back and show you what's there. Okay, part of the fun of this process is the printer and how it printed. For instance, this hole should be a clear running 6mm fit. Instead, it's snug. The same with this section here. I did set up to thread this end of this, but this should be a free 6mm clearance as well. And instead, it looks like it actually it threaded it instead, because that's actually a good thread. So I need to drill out this half so I can clamp, and I need to drill a clearance here so it'll run smoothly. To do that, I'm going to use a 1/4 inch, which will give me a nice loose fit. Or should I use the, what is it? Can't even read it. 11/64. Let's see what 11/64 feels like. That might actually do it. Anyway, so let me set that up and then we'll go a-drilling. What a boring thing, I know, but what the heck. Well, isn't this fun? There's not enough clearance under here. There ain't not enough clearance to even get the part underneath. I may have to go to a bigger drill press. This little critter just doesn't get the job done. Anyway, so I'm going to have to do this by hand. I'm not going to show you guys that because, frankly, that would be too messy. Bye. Okay, we're now set up with a nice, loose rattle fit on these holes. This stud, by the way, here was something I was going to use on another project. But the way this works is the dial gauge. See, dial indicator. Let's see how that hole came out. This one's never been used. I've got an old beat up one around here somewhere. This fits into here. Yeah, of course. This fits into here. Yeah, sure it does. This fits it. Okay. So, I guess not. I'm going to have to open that up. Teach me. The lesson learned here is don't trust a 3D printer to print on size, because this one didn't. But what will happen is that gauge will go in there. We'll then set that up on the table, put this in the spindle, measure here, swing it around to the other side, measure the other side, and that tells us the tilt in the table. These are running again on V blocks down here, so when you tighten this up, tighten this up, there we go. That all clamps together, the V's pull everything together, and that is stable as heck. And then, of course, the clamping will go on here. But I am going to have to bore this hole out bigger. Well, rats. So I'll be back after I do that. So, anyway, here's the completed assembly. As I said, the dial indicator goes through the hole, the clamp here clamps. This goes into the spindle, and this, of course, could be used to adjust this along a little ways here. So it can come in, he probably even couldn't get that close to the spindle, all the way out to something far bigger than what I've got on this table. Anyway, so if you guys have any questions on this, I'll be more than happy to answer it. If you want the files, I'll put them in this. You just let me know, and I'll get them to you one way or the other for the fixture. The only thing I'll point out is that on my printer, this printed up under size. But with just a few minutes of time on Fusion 360 and a little bit of time on the printer, you two can have a handy-dandy tramming fixture. That's all I got for you right now. If you like what I'm doing, please think about giving me a like or a subscribe or both. Thanks much. I hope your day goes well.